Assalamualaikum warahmatullahi wabarakatuh, and hi everyone. I wish for those who watching my video, especially my favorite lecturer, Dr. Afian Akbar bin Mustam. Today I will present to you guys about my continuous assessment for subject curriculum studies and learning theories in primary school mathematics. First of all, my name is Muhammad Syami bin Ahmad and I'm from class Maths 2. Alright, let's begin with the introduction. Learning theories help us to understand how students learn, which means learning theories help us to know how the best way that student can learn for a particular subject. In maths, these theories guide teacher to create a lesson that helps students think, explore, understand concepts step by step, which means the cognitive learning theories focus on how students think and solve the problems, while the constructivism encourage students to actively explore, work together, which means they collaboration with friends and share some ideas and discover ideas on their own. So these have 5 cognitive learning theories, which is Piaget, Brunner, Gardner, Ausubel, and Dionys. Alright, for this coursework, I have to create a lesson that's using a cognitive learning theories and also the constructivism, but we don't have to use all the cognitive learning theories. You have to choose. So I choose a Piaget and also Brunner and also constructivism. So I combine these two theories and also constructivism into a one activity in class. Alright, before we go further ado, let me explain to you guys about the surface about the Piaget cognitive learning theories, Brunner's learning theories, and also constructivism. Because of why? Because we don't know about the cognitive learning theories and also the constructivism, we can't understand about the activity that I want to share with you guys. So let's begin with the Piaget's cognitive learning theories. So what is the key idea? What is the simple sentences to explain about the Piaget's cognitive learning theories? So children progress through a stage of cognitive development: sensory motor, pre-operational, concrete, operational, formal, operational. So learning happen through active exploration and building schema in children's brain. So what is the application about the Piaget's cognitive learning theories in mathematics? The first, use hands-on activity like a manipulative, like a counters and block, which is hands-on things for a younger student. This is the concrete operational stage. And the second one is encourage discovery learning, where students explore a pattern, for example number sequences and also shapes. And the third one is for older students, promote abstract thinking like algebra and proof. And then for a teacher, this is important for teacher to know about the individual differences, which is student differences in learning ways. So some students might still rely on the concrete materials even when their peers are ready for the abstract concept. So teachers should adjust the material accordingly, which means teacher should know how the effective way to understand the children, to make children understand about the particular subject that teacher teach, to understand that. Alright, next for the Brunner's learning theory, which is a discovery learning. So what is the key idea or a simple ways to explain about the Brunner's learning theory is learners construct their own understanding through active discovery, moving from a concrete to a pictorial and to an abstract, which is this 3-stage is a CPA approach. So what is the application of Brunner's learning theory in mathematics? So we use the CPA to approach for a fraction. For the example, fractions. So 1, start with fraction types, which is a concrete, and second one, move to drawings, pictorial, and 3, finally work with the fraction symbols, which is the abstract. So this encourage students to discover the formula like area formulas through a hands-on activity. So the individual differences also important for these learning theories. Some learners might need more time at a pictorial stage before moving to the abstract symbol. So we as a teacher, we can make the student more understanding about the subject that we teach. Alright, next let's move on to the constructivism. What is the constructivism? So the key idea of this constructivism is learning is an active process where learners build their own understanding based on the prior knowledge and experience, which is this based on the observation of the student. So they learn from the observation that they did, so they use and understand about it. So what is the application of constructivism in mathematics? First, use inquiry-based learning, which is present a problem with a multiple solution and let students work collaboratively, so they can share each other their ideas. So the second one is encourage group project, where students explain their reasoning, so they can share their idea lah. So individual differences, group work allows students with a different strength to support each other, and open-ended problem give a room for a creativity, so they can share their idea and creativity to solve the problem. So it's help a weak student to understand about the question and how to solve the problem. And now let's enter to the activity that I create by using the Piaget's cognitive learning theories and also Bruner's learning theory and also constructivism. So I use these three to create an activity in a class, which is for a subject mathematics, for a topic geometry, which is a tessellation. Because in my coursework question, we have to include the knowledge of geometry in that I studies in other subject. So yeah, this activity is the application of learning theories, which is Brunner and Piaget's, and also constructivism in mathematics activities. So the title of my activity is exploring tessellation through hands-on discovery, which is this activity is to help students understand the concept of tessellation by exploring the pattern, shapes and transformation through a hands-on and collaborative activity applying cognitive development stage, representational modes and active learning principles. So yeah, this is the materials that I used for this lesson activity, for this tessellation activity. So let's move on to the objective activity. So first one is to understand the concept of tessellation and how geometric transformation, which is this translation, rotation and reflection, applied to the tessellation. And the second one is to discover and analyze which shape tessellate and why based on the mathematical properties. And 3, develop their own understanding through hands-on exploration and peers discussion rather than the direct instruction, which is the important things that in the activity. And the fourth one is transition from concrete manipulation, which is the hands-on, to the abstract reasoning, which is the symbolic of representation, following the Piaget's and Brunner's theory. Alright, this is the part that we waiting for. So I will explain to you guys about the step by step of my activity, and I will explain to you guys what's the what is the learning theories that I use, and the constructivism step by step. So the first one is step 1, hands-on shape creation, which is a concrete stage, which is Piaget and Brunner. So each student creates a basic polygon shape, which is a triangle, square and hexagon, using a cut paper. And then students physically move and fit this shape together on the grid paper, experimenting with a different arrangement to see which shapes tessellate perfectly. So what is the Piaget's links and the Brunner's link in this part? So Piaget's link, this stage supports student development in Piaget's formal operational stage, where they can handle abstract concepts like a transformation but benefit from starting with hands-on experiences. And the Brunner's link is, this is an inactive mode student learn through a manipulating real object, which is they cut the basic polygon shape and they try to put it together and fit this shape together on a grid paper. So it's tessellate perfectly. Alright, for the step 1, how we support the individual differences, how we support the student differences. First, visual learners. Seeing different tessellation pattern develop make concept clearer. And the second one is kinesthetic learners. Cutting and arranging shape help them learn by doing it. And the third one is advanced learners. Encourage them to create a irregular shape and explore whether they tessellate or not. And fourth one is struggling student. Start with a simple shape like a square and triangles before moving to a complex one, which is we add more polygon, which is the hexagon. So, and the last one is student with a motor challenges. So provide pre-cut shapes to reduce the frustration. That's me. Teacher can provide a pre-cut shape that already pre-cut shape, so they just have to make arrangement of a tessellation perfectly. Alright, next is step 2, which is a visual representation, which is a pictorial stage from the Brunner cognitive learning theories. So pictorial stage is a CPA approach, which is a second stage. So after exploring with a physical shape, students draw a tessellation patterns on the grid papers. They use a color coding to emphasize repeating units and pattern. So what's the Brunner's link for this step? So this use the iconic mode, transitioning from a physical shape to a diagram, helping students to visualize the mathematical structure behind this tessellation. So it helps students to more understand about the tessellation that happen from the hands-on to a diagram. Alright, for this step 2, how we support the individual differences, how teachers support the student differences. First thing first, student who struggle with drawing. So teacher can allow them to use a grid paper or a digital tool like a GeoGebra for accuracy. So it helps student to more convenience for drawing it. So the second one is color blind students. So we can use a pattern or a symbol instead of relying on a color coding. So the symbol of a pattern can determine the color coding for them. So, and the third one is logical thinkers. Encourage them to identify the repeating units mathematically. Alright, for the step 3 is collaborative discovery and discussion. Like before, I told you about the collaboration. So it's based on the constructivism. In a small group, students can compare their tessellation, discuss why some shapes tessellate and others do not, and record the rules and properties like an interior angle and edge-to-edge fitting. So the teacher acts as a facilitator, asking guiding questions such as why do squares tessellate easily, what happens if you use irregular shape, and how do the translation help to create this tessellation. So where the constructivism happen? The constructivism happen when the student construct their own understanding through exploration and collaboration from a group discussion, and peers discussion instead of being directly told the rules by the teacher. Alright, from this step 3, how we support the individual differences. First one, shy or introvert student. So the teacher can allow them to participate in a small group discussion before speaking to the whole class, which is they can discuss each other and gain some knowledge before speaking to the whole class. And the second one, student with a language barriers. So encourage a visual explanation instead of relying on a verbal discussion, so they can use a slide to explain their knowledge and others. So fast learners, challenge them to predict the rules about the tessellation using a mathematical reasoning. Alright, for the step 4, abstract mathematical explanation, which is a symbolic stage, the last stage of CPA approach in a Brunner learning theories. So groups create a summary poster or slide explaining what is the tessellation is, example they create, and mathematical properties. So they label their tessellation diagram with a transformation rules and explain how the translation works in their patterns. And also, students who struggle with the formula receive additional visual aids to support their learning. So it helps students to more understanding about the tessellation. So where's the Brunner's help in this step? This step corresponds to the Brunner symbolic stage, where the student transition to abstract mathematical thinking, which is the formulas and the algebra rules, and they now express the pattern and the transformation using the mathematical notation, completing the CPA, which is the concrete, pictorial, and abstract learning progression. So from this, we know that Brunner's learning theories help students to more understand about the tessellation. Alright, for this step 4, how we support the individual differences. The first one, students who struggle with writing, let them create a label diagram instead of full sentences, which is they just use a simple way to label the diagram instead of using a full sentences. And the second one is students who need extra help. Teacher can provide a guiding question and sentences starters for the explanation. So it really helps students to more to start explain about the diagram. And also the verbal learners, allow them to explain their finding orally rather than just writing them down. So it helps students to gain more confidence and communication skills. Alright, for the step 5 is presentation and reflection. Teacher can ask students to make a presentation and also reflection from this activity, which is a tessellation. So objective to summarize and communicate key findings to reinforce the learning. So each group present their findings to the class using a visual example like drawing or digital tessellation, mathematical explanation why the tessellation work, and transformation rules. Teacher leads a reflection discussion. Teacher should lead the reflection discussion, like how did hands-on learning help you to understand the tessellation, and what the challenge did you face and how did you overcome them. So where the constructivism happen in this step. So this reinforce student-centered learning, allowing students to reflect on their learning journey rather than just memorizing the rules. And the second one is peer teaching, enhance deeper understanding and a long-term retention. So from this, the constructivism helps students to gain more knowledge about the tessellation and remember that for a long term. So they can remember the tessellation, what's the tessellation happen, and how to make the tessellation for a long term. Alright, from this step 5, how we teachers support the student differences. First one, student who struggle with public speaking, we can allow alternative presentation formats like record a video or group presentation, so they can reduce their nervous and also make a presentation when smooth. And the second one is reflective thinker, provide time for individual journaling before the discussion. And also the third one is hands-on learners, encourage the demonstration using a physical model while presenting. So it helps students to remember the tessellation words. So guys, this is the part that I want really to show to you guys. What is summary of learning theories applied in this activity, in my activities. So we have three theories, which is Piaget, Prunus, and constructivism. So what is the application in the activity? For the Piaget, hands-on experience, which is the concrete operational to formal operational thinking, helps students to develop the abstract reasoning, which is they cut the shapes and they try to form the tessellation, arrange to tessellate the shape perfectly. And the second one is Brunner CPA approach, which is an active hands-on shape to the iconic diagram to a symbolic math notation, which is a progression. And the third one is constructivism, active learning, peers collaboration, and guide discovery helps students form their own understanding of the tessellation. So from the collaboration and make a discussion, they can understand more about the tessellation, how it's work, and how to make the tessellation looks better. So, the conclusion of the activity, by combining the Piaget's development stage, Brunner's models of representation, and also constructivist principle, this activity provides a progressive and engaging ways to teach a tessellation. It ensures students actively explore, discuss, and apply their knowledge in a meaningful way, fostering deep understanding rather than memorization. By considering individual differences, we ensure every student can engage, learn, and succeed in this exploring tessellation. So, these three learning theories, which is the Brunner's learning theories and also Piaget and also constructivism, helps teacher to make student more understand about their particular subject. For like this example is tessellation. Alright, I want to share to you guys about the application of learning theories and constructivism in mathematics activities. For the first one is Piaget's cognitive development theory, design activity that align with a student developmental stage. For example, for students in the formal operational stage, like a 19 years old, provide abstract problem solving tasks such as proving the properties and of transformation in geometry. For the second one is Brunner's learning theories. Apply the concrete pictorial abstract, which is the CPA approach, to help students transition from hands-on activities to a symbolic representation. For example, in a tessellation activity, students first manipulate the physical shapes, which is the concrete, then draw a pattern, which is a pictorial, and finally describe them using a mathematical transformation, which is the abstract. So it helps students to gain more knowledge and more understanding about the tessellation. And the third one is constructivism. Constructivism encourages students to construct their own mathematical knowledge through the collaborative discussion with friends, either with teacher or friends, and exploration and real-life application. For example, have students work in group to discover the condition for the tessellation instead of directly giving them the rules. So, from the teamwork, from the discussion, they gain more knowledge. They share each other idea, so they can more understand about it. Alright, next I want to share to you guys about the implication of cognitive learning theories and constructivism in teaching mathematics, specifically to the Piaget's learning theories and also Brunner's learning theories. Addition, the constructivism. So the first one, enhance deep understanding. Students actively explore the mathematical concepts rather than just memorizing the formula. So the benefit is they develop a problem-solving skills and a strong mathematical foundation. Okay, like based on the activity before, students explore the tessellation hands-on by manipulating physical shapes, drawing patterns, and identifying transformation properties. So the benefit from that, instead of just memorizing the rules, students discover why some shapes tessellate and others do not, leading to a deeper conceptual understanding. For the second one is support different learning paces. So learning progresses from a concrete to the abstract, allowing students to move at their own pace. So the benefit is struggling students get extra support, while advanced learners are challenged. So based on the previous activity, visual learners identifying tessellation patterns in drawing. So kinesthetic learners manipulate paper shapes, and auditory learners discuss observation with peers. So from that, the benefit, each student learns in a way that suits them, making the lesson more inclusive and effective. So the student will more understand about the tessellation. So it is proof that the Brunner's learning theories and Piaget's learning theory and also constructivism give some benefit in teaching mathematics. Alright, for the third implication of cognitive learning theories and constructivism in teaching mathematics, it enhances learning more engaged. Hands-on activity, real-world application and discussion make enjoyable. So the benefit is students stay motivated and interested in learning mathematics. Okay, based on the activity tessellation before, the activity involve cutting shape, arranging them on a grid paper and working in group, making a learning fun. So the benefit is hands-on activity increase motivation and reduce maths anxiety, making students more confident in exploring geometric concept. And the fourth one is encourage collaboration and communication and develop a critical thinking. This is the important part of in teaching mathematics. Group work, discussion and peer learning help students exchange ideas and clarify misunderstanding. So the benefit from that is improved teamwork, communication skills which are useful beyond math. So from this past activity, students work in group, discuss their findings and justify their reasoning about the tessellation. So the benefit is peer discussion reinforce learning and help students clarify misunderstanding while improving communication skills. So from that, they can improve the communication skills and clarify misunderstanding about the tessellation. So it gains some knowledge about the right tessellation. Alright, for this one is the implication or the benefit of cognitive learning theories and constructivism based on the individual differences. The first one is personalized learning for every student. Different teaching strategy address various learning styles, which is the visual, auditory and kinesthetic. So the benefit is every student finds a method that works best for them. And for the second one, the cognitive learning theories and constructivism help to support the different cognitive abilities. Some students need to concrete the example before moving to the abstract thinking, like a Piaget story. So the benefit, students learn at a pace that match their cognitive development. And the third one is encourage student autonomy. Students take a control of their learning by exploring the multiple problem-solving approaches. And the fourth one is allow flexible assessment method. And the fifth one is promote inclusivity and equity. Alright, for the conclusion is cognitive learning theories and constructivism help make a mathematics engaging and meaningful. They encourage students to learn by doing, starting with hands-on activity and moving towards abstract thinking. This approach not only deepens understanding of mathematical concepts but also adapt to different learning styles and needs, ensuring every student can build a strong foundation in mathematics. So that's all from me. Thank you for watching my videos, and I hope this activity helped the teachers out there to improve their learning skills for the student to understand more about their subject. So that's all from me, Muhammad Syami bin Ahmad. Thank you very much.